Hello everyone. In this episode, we're going to start working again on the CI YAML file that we've been working on, but now we're going to be adding more to it. This time, we're going to start making our CI actually execute some script that we have in our repository. So, as of right now, your ci.yaml file should look like this. We can also open it here. And that's exactly what we have. And so let's go ahead and let's try to build our code that we have in our repository. We can make another job called build skim. So let's actually do that. Build skim. And then what we want to do with this new job is we want to run the compiler that root uses, and here's how we're going to do it. So because this usually works on a computer that has root installed, we can probably go ahead and do something like this. All right. Can probably do something like this, but this doesn't seem quite right. Right. Because these are commands that are going to be run as a script. And so now that these are run as a script, indentation again. And yeah, this should be fine. So what this is doing is we're defining here the value for the root, the compiler that root is using, and we're using that compiler to try to produce this skim binary from the skim.cxx file that we have in our repository. We can confirm that that is in fact in our repository if we click on the virtual pipelines and then selection. And just because we're in the feature branch, let's just go there for now. And yeah, that file is in there. So we should expect that the CI is aware of the files that we have in our repository, and that something like this should work. Here's what the solution would show you. So this is how the script, how your YAML file would look like. Yeah, similar enough. That's fine. All right, so now that we have that, let's actually save this file. Commit -m, adding build skim job. And now let's push it. All right. So now let's actually check over here. We can, let's see, go ahead and refresh. Oh, so it seems that that failed. Let's try to investigate why. All right. We can look at the log of the runner. And let's see if we can find out what's happening. It says root config not found. Okay. Why would this be? Well, we were a little naive. And it seems that we have a broken build. We see something like this that you will see in the documentation. No root config found. So what happened is basically we didn't have root installed. And what we can do is then let's actually add as part of our script the installation of Anaconda or Miniconda to be specific. And then we're going to use Conda to set up root and run this. So I'm just going to copy this for now. And since at this point, I'm going to be working a little bit more on editing, and I want to be sure that I get the indentation correctly. I'm actually going to change editors. So let me clear the screen, and I'm going to be using VS Code for the remainder of this episode and possibly the rest of this series. All right, let's actually see. Okay, so opening this file, I'm just gonna paste this right there. All right, and that looks correct. So what we're doing here is we're downloading Miniconda, and we are initializing and installing root. All right, so let's try that once more. I'm actually going to pop up the terminal that I have here on my VS Code. Git status. Yep. Git add.gitlab. Git commit -m. Installing conda and root. And then git push. Alright, that pushed. So now, again, from here, I can click on this little tab and then click on the pipelines or click on the branch. Let's click on the branch so that we can see the commits, and we can see that this pipeline is running. Let's click on the pipeline. Okay, and we can still click on this blue button. It says it's running, so let's click on that and let's see what it's doing. Seems like it's preparing some things. It's waiting for some pod. This shouldn't be too long now. All right. So we can see in green that it's actually running the commands that we have listed in the script. So that's good. We're already installing root. This will take a little bit of time because sometimes runners have the shared runners at CERN have some cache, and they will recognize that this environment is already similar to something that was run before, and that will speed up the process. But we didn't have that locked this time, so it'll just take another minute. So we have another error, and it says here that no such file are data frames, scheme.cxx compilations. So it seems to, something seems wrong here. Let's see what might have happened. So it turns out that we do have root installed, but we forgot to include the needed flags because it seems that we forgot to specify how it should compile. So we can basically just add this line to our file that defines the flags, and then we can simply include it here, flags. That should be enough. Adding root flags. And now we get to wait all over again, see what happened. Let's actually click here to scroll to the top, click on the feature branch, and it's already running. Let's see if it goes faster this time. And let's wait. All right, so that took a little while to run, but through the magic of editing for you guys, it might have taken a few seconds. And so eventually it actually ran, and we have a successful job. So that means that we have successfully installed conda and root, and we have compiled our code. So yay, that's good. So another thing that we can do is to really take advantage and leverage the power of CI, running multiple jobs in parallel, as is the default behavior of the CI. And so we can actually test out that this code also runs for different versions of root. Okay? And so for that, what I am going to do, let's just look at the solution here, and I'm just going to copy and paste what we have here. So the entire thing. All right, through a little bit of editing, what I basically did is I copied and pasted this code right here to the left. I fixed some indentation, and yeah, so that's it. And the reason we're doing this is because, again, we want to build multiple versions to take advantage of that the CI can run multiple jobs in parallel. However, I also added this thing right here at the bottom of the build skim latest job, because suppose we want to test out, we don't want to test out two jobs that are exactly identical. We want to check whether there's a possibility that, you know, this job runs but this particular job fails, and we want to keep our pipeline to pass. We want to have our pipeline still pass, so we can consider this second job, build skim latest, to be an acceptable failure. And so by adding this allow failure equals to true key, we can tell the CI that even if this fails, we can ignore that one and consider the entire pipeline to be a pass. All right. So after that, what we can also do is we can start thinking about cleaning up a little bit the jobs by separating out the parts of the script that have to do with initialization and setup, and the other parts of the script that have to do with the actual compilation and installation and compilation of the code. So we can do something like this, and we can do that for both of these jobs. So we can add what's called as a before script. So we're going to give it instructions, actually just move these instructions so that they run before the actual script that we want to evaluate is run. And same goes for here, before script. Oops, I seem to be missing one. I might have copied it incorrectly. No problem. All right. Everything is looking good. All right. So now that we have that cleaned up, let's actually test it out. Let's see how that looks. So git add. I want to add cleaner jobs and then git push. All right. And now we can also evaluate the commits of our branch. We see that this is running. And we have all 3 jobs. So the hello world job already ran. Now we are waiting on the build skim and build skim latest. So let's actually look at build skim latest. All right, and through some editing magic again, we have arrived at the success at the end, as a successful end of this particular job. All right, so let's go back and let's go back to the documentation. So this is looking good. Now, sometimes you might find that certain jobs don't need to be run all the time. For example, we've seen that every time I make a change in this YAML file and I push it, the GitLab CI will automatically execute all of the jobs. But we can choose which particular jobs get run all the time, or if there's any specific instance when a specific job should be run. And so, for example, our job only depends on the skim cxx file, and we can emulate the fact that there is no makefile solution in GitLab, but we can emulate this with an only changes on the skim cxx file, like so. So we can add here below the script only, and the only time I want this particular job to execute is when there are changes to the skim.cxx job, the cxx script, sorry. And now, again, we can run this, change our commit message, run only on skim changes. And again, we wait. But again, there's plenty more of things that you can do with this. This is just one example of how you can control when a particular job runs and how often. So feel free to check out that on your own time. But that will be all for this video. Let's actually verify that our job is actually running. And let's go to the pipeline. Yep. And because there is actually no changes on the CXX file, this build skim job is actually not running. Hence, it doesn't show up here. All right. So that's it for this episode. See you on the next one.